we're going to talk about properties of diagonals of a rhombus and a parallelogram. Then we're going to use those properties to help prove that quadrilateral is a rhombus or a rectangle. I think I misspoke. A rhombus or a rectangle, not a parallelogram. Okay? So, there's going to be 6 theorems we're going to talk about. All right? 6 theorems we're going to talk about. The first one simply says each diagonal of a rhombus bisects 2 angles of a rhombus. Okay? Each diagonal of a rhombus bisects 2 angles of a rhombus. So if I have a rhombus here, and it's a little crooked, it may not be perfect, but if I drew my diagonals in, what this rule is saying, this theorem is saying, is that these angles are equal, and these angles are equal, and these angles are equal, and these angles are equal. So we're saying this long diagonal up and down bisects 2 angles, the opposite angles, and this horizontal one also bisects 2 angles, the opposite angles. Okay, so each diagonal of a rhombus bisects the angles. Okay? It says diagonals of a rhombus are perpendicular, and the third one says diagonals of a rectangle are congruent. Let you copy that down, then we'll draw the board. Number 2, the diagonals of rhombus are perpendicular, so if we draw these in, oops, I missed my mark. We draw these in, what we're saying is that this angle right here at the intersection is a right angle. Okay? Perpendicular means that we're creating right angles there. And so any rhombus, if we see it's perpendicular, then we know that well, I have to be careful. There's other figures that this would be true for also, but this is true for all rhombuses. Okay? I have to be very careful how I say this. So we'll just go with, if we're looking at a rhombus, then we know that the diagonals are going to be perpendicular. Okay? And then the third one here, the diagonals of a rectangle are congruent. Oops, there. Let's actually use a line. We're going to play around with this one a little bit in a few minutes. I don't know if you're aware, if I've talked to you a lot about it, but I've done quite a fair amount of building in my lifetime. I helped my brother build a house, and I helped my other brother build a house, and I built 2 houses of my own, and I built a barn and a couple garages, and grew up on a farm where we built barns and different things. And so I've been fairly active. Well, this concept right here is one that I use all the time if I want to make sure that my slab of cement or my foundation or my post are all in the ground in the form of a rectangle. Okay? You can measure from corner to corner and get the same distance, then you know that it's going to be a rectangle. Okay? The rectangles, so what we're saying here is whoops, sorry. What we're saying is that segment, let me try it again. The distance from R to C is equal to the distance from T to E. Okay? Diagonals of a rectangle are congruent is saying that the distance from this opposite corner over to here is going to equal the distance from this corner over to its opposite corner. Okay? That's what it is to be a rectangle. Okay? And that's pretty unique to rectangles. Okay, a square is a rectangle, right? Remember, to be a rectangle, it has to have what? Well, that's true of a rectangle, but that's not what it takes to be a rectangle. 4 right angles. Okay? Remember, to be a rectangle, it has to have 4 right angles. Okay, well, a square has 4 right angles, right? So this would also be true for squares, but it's not going to be true for any of the other shapes we have. If I took a parallelogram, and with this feature I can't really do totally what I want, but if I took this parallelogram, and I do this, you can see those diagonals are definitely not going to be equal. Do you agree? Okay. Well, as I get closer and closer to here, to the square, then they might be. But see, this feature won't let me make this a rectangle. Now it's getting close. Well, maybe. Yeah, right in there, we're getting close. It's still not, but it's getting closer. And so what's happening is my diagonals are getting closer and closer to equal. Okay? So this is unique to a rectangle, and that's why it works really well if you're ever, you want to pour some cement out in front of your garage, or you want to build a little pole barn or shelter for your horse or whatever. You want it to be a rectangle, you can measure corner to corner. Okay? You can also use Pythagorean theorem to help you know what that measurement should be based on the lengths of your sides. But we'll get into that more later. Okay? Any questions on what I'm talking about here? All right. I want to play around with this just a little bit. Example here, we're asked to pour a rectangular, a rectangular slab of cement in front of the garage. Okay? Here we have our house and our garage. It's actually basically the shape of mine. And I have here some form boards. Okay? I'm going to use the existing garage wall as one of them, but I have 2 boards here that are this long, and I'm going to put them in here. You just can kind of watch. Now, this isn't quite fair because in this picture, if I touch my boards, I can swing them around, but it also changes the length of them. You see what I'm saying? So I can't just swing this. So as I created this in this program, it really is difficult for me to create a parallelogram and prove to you how to make it a rectangle. Okay, it's hard to play with this that way. So what I have, and I say that because when I make these lines, this kind of snaps into place when it gets to perpendicular or to vertical. And this one kind of snaps into place when it gets to horizontal. And remember, we talked a while ago that when we were talking about slopes, perpendicular lines are equal to -1. The product of the slopes of perpendicular lines are equal to -1. And then they had a little disclaimer because a vertical line is undefined slope. So they said vertical and horizontal lines are perpendicular. That was their disclaimer. Well, this is already going to be perpendicular. But what I wanted to do is just show you, if I measure this, okay, I get 4.8. Would you agree with that? Yeah? Okay. And so, if I move this over here, and measure this one, what do I get? 4.8. Okay? And so, that shows that I've got my boards in the shape of a rectangle. Okay? And so, if you were doing this out in your garage, you might have some strings, you might have some stakes, or sometimes it's easier to use screwdrivers that go in and then put your boards in better later. But you can use strings and you can swing them around and get your measurements right, and then go ahead and measure and make some adjustments, okay? But I just want to show that this rectangle, the diagonals were going to be equal, okay? Forcing it to be a rectangle. All right, now we have three other theorems here that look very similar to the ones we just had. Right? Look very similar to them. It says if one diagonal of a parallelogram bisects two angles, then the parallelogram is a rhombus. Okay? If one diagonal of a parallelogram bisects two angles, then the parallelogram is a rhombus. So remember before we said if it's a rhombus, then the diagonals are going to bisect the angles, right? Now we're saying if it's a parallelogram and one of the diagonals bisects opposite angles, then it's got to be a rhombus. Okay? So we're switching it around. It's basically the converse. We're starting out, instead of knowing it's a rhombus, we're proving that it's a rhombus. And it's like minimum criteria to prove that it's a rhombus. All right, I see you're engulfed in copying, so I'm going to pause while you finish. Okay, here we go. We've already talked about number 4. The second one, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. The key here is we're not just starting with any four-sided quadrilateral. We're starting with a parallelogram. Oh, let me try that again. We're starting with a parallelogram, okay? And as I read through one of these myself, I'm thinking, well, man, that's true of kites. And then I realized, oh no, these are parallelograms, okay? And a kite is not a parallelogram. Remember, we said definition of kite, opposite sides cannot be equal, right? And so in this one, we're saying all of these are parallelograms. So you're not just starting with any four-sided figure. You're starting with knowing it's a parallelogram. And then if the diagonals are perpendicular, then that's another reason to know it's got to be a rhombus, okay? And if the diagonals of this parallelogram are congruent, then it's got to be a rectangle. So if we know that it's a parallelogram and the diagonals are congruent, then it's got to be a rectangle. Okay? And again, the definition of parallelogram is two sets of parallel sides. And then remember, one of the rules to be a parallelogram was if opposite sides are equal, then it's got to be a parallelogram, right? So in our little construction project we were talking about, I made sure the opposite sides are the same length, and that meant it had to be a parallelogram. And then if I make sure the diagonals are equal, then that makes it have to be a rectangle. Okay? Any questions on these? Okay, we're going to do another activity here in just a moment. Your assignment's going to be, though, 3 to 48 by 3s. There's only 16 problems there. You're going to have to write an equation based on the information they give you to solve, to prove that it's a rectangle or that it's a rhombus or whatever. Okay, similar to what we've been doing all along. But I want us to come together and play. Some of you walked in and said, what are these boxes about? Well, I don't have enough boxes for every group, so I'm going to ask groups to get together. And I guess I don't need to record this.